Good morning everybody and welcome to today's special episode. If you've been following the channel, you know that I recently got promoted to Dr. Graves, which I believe gives me just the credibility I need to do an Engineer Reacts episode. And being a long-time fan of movies and a bit of a movie buff, I figured this would be a great time to react and maybe explain the engineering in some of your favorite movies. What have we got? We've got Chernobyl. I haven't actually seen this, so this could be interesting.
Fully withdrawn control rods begin moving back into the reactor. These rods are made of boron, which reduces reactivity, but not the tips. The tips are made of graphite.
Okay, this is right so far, yeah.
Reactivity. Water-cooled, graphite-moderated reactors with a positive void
coefficient. Yeah. Wow, okay, so this is actually really impressive, just how accurate this is. I know a bit about this incident, so I can tell you that they've used the right figures, they've explained correct operation and what happened really. They're saying here that putting the control rods back in was the thing, like the main issue that over-accelerated the reactivity in the reactor.
And when they do, the reaction in the core, which had been rising, skyrockets.
I don't know if that's the case. As I understood it, the reactor was already increasing massively and there was already a major issue. So they tried to put the control rods in to just kind of calm it down, but in fact, due to the design and the tips, it just kind of made things worse, if anything. But I don't know if that was kind of the main catalyst in that regard. But that's just a minor point because at the end of the day, the result was the same. What I really like about the scene and what I think is very impressive is that they haven't tried to over dramatize it like you would typically see in a Hollywood. You know, they've actually used the correct terminology even, potentially at the expense of the audience's understanding. Here's we have Terminator 3, definitely not the best, but probably not the worst either. Here we have the TX, I think she was called in this one, and she is controlling these cars remotely. Okay, so I think I've seen this discussed before as to whether this is possible, and long story short, in this particular instance, no. You could argue that she's infecting the car with some kind of nanites maybe that can, I don't know, replicate and mechanically control the car in some way, but that's kind of not what's really shown here. What's shown is a circuit board with power running through it, so it's suggesting to me that there's an electronic control going on. And I used to actually work for Jaguar Land Rover, so I used to play around with this kind of thing. And when I would tap into the cars, you would see this big long screen of different sensors and different actuators and things going on. And you could see the readouts. You could see whether the doors were open, or you could see whether the brakes were on, and it would tell you these things. And one thing you could do if you wanted to be cheeky was you could, instead of reading that value, you could type a different value in. You could tell it that the windows are open. And while that works in theory, what actually happens is you just get an error because the sensor's telling you one thing and you've just told it something else. But that's not to say it's not possible. If you're sophisticated enough in how you do it, and you can disable the sensors and you can explain to the car in certain ways what it's doing, you can basically override the signal from the sensors, then yes, you can tell a car what to do. And I would even argue that with a lot of modern cars, you could control them in this way entirely. That being said, this movie was, early 2000s, I think? You've got what looks like late 90s or early 2000 Crown Vics, I'm guessing, and quite an old looking fire truck. Now, these would not have the same sophisticated electronics as you would have nowadays. You're gonna have power steering, you're gonna have manual throttle control. None of these things are going to be electronically controlled. No matter what technology you had, there was no way you could electronically control these vehicles in this way. So as much as I love the Terminator franchise, I'm sorry, but this one is a no from me. So, okay, I haven't seen this movie actually. I've heard about the suit. The suit is what we're going to be talking about. I'm an energy guy, so of course we're going to talk about the suit. Okay, so he's taking bullets, a lot of bullets. Okay, so as I understand the technology in the suit, he's taking bullets and his suit captures the kinetic energy from the bullets and it stores it. So this is literally energy harvesting. This is what I've been doing for the last 4 years. So theoretically, currently there are materials that do exist, primarily piezoelectric and triboelectric materials, that allow you to harvest from small displacements in that kind of flexible weave pattern that you would have with a suit. Those are the only two technologies you could use. Now, the problem with those technologies in this regard, as they currently stand, is that you're looking at the most, usually microwatts, sometimes milliwatts of power. But that's because currently we can't harvest all of the energy from a large impact like a bullet. So currently there is nothing even close to being able to do this on this scale. Theoretically, Can you get a material that can disperse the energy from a bullet? That's basically what Kevlar does. If you look, Kevlar doesn't just stop a bullet. It works by dispersing the energy throughout the weave. Could you find a way to harvest the energy from that? Maybe if someone provides an alternative method of energy harvesting in the future. But as the technology currently stands, we are a very, very long way off from producing anything that's capable of stopping a bullet. What's he going to do next? I assume he's going to use the energy in a minute. Whoa! Okay, so that seems like a bit of a step for me from a few bullet hits to blowing up a car, but as I understand it, I think like a 5.56 round has about 1.5 kilojoules, which is less than you would think just due to the fact that the mass of a bullet is so small. And I think like a 7.62 is probably about 2 kilojoules. You know, assuming he's taken a couple of dozen hits there, let's be really generous and say 50, about 100 kilojoules of energy that could potentially be extracted by the suit. He's then hitting a car, and the car is gaining enough energy to essentially travel about 2 meters up in the air in terms of its center of mass. It's a big car, it's like an SUV, so probably about 2 tons going 2 meters. That's 4,000, and then you've got your gravitational constant 40,000, so you've got about 40 kilojoules required to do that to the car, and he's arguably getting maybe 100 kilojoules out of the bullets. So if you assumed infinite technological advancement and somehow like 100% efficiency, maybe he could actually produce that energy from those bullets. But right now, definitely not. Sci-fi though, it works. Okay, so this is Sense 8. This is the last episode. Okay, first of all, if you haven't seen Sense 8, watch it. Honestly, it is... I cannot stress enough how underrated it was. Honestly, just one of the best series I've ever seen. There's one thing, one little trope that they fell for, they put in there, and it just why did they feel the need? Okay, so just let's go through it. So you don't need to be an engineer to explain this. Anyone who's ever done a paramedics course, I did a first aid course with the police. You know, if you've ever used a defib, you understand immediately how it works. But from a technological point of view, as an engineer, a defib has a rather specific voltage and current combination, which is correct and sufficient for kicking a heart back into rhythm. A taser produces an extremely high voltage, low current shock designed to basically make you pee yourself. I mean, stun you. And they're vastly different in what they present. It's like me trying to charge a phone by just attaching it to a pylon. It's a little note to all directors, writers, anyone remotely related to TV productions or movies. Stop doing it. Stop using cables and car batteries and tasers and just anything that apparently has electricity, because all electricity is the same apparently, to restart people's hearts. It just doesn't work. Just don't do it. Just stop doing it. It's like in a medical drama saying clear and they're all still touching the person. Where did I see that? There was a show. I watched a show where they were just like, clear, and they were all just holding the person still. Like, do you not think there's a reason they say clear? Maybe there's electronics involved. Maybe there's a bit of a shock coming. Maybe you shouldn't be touching the person that's about to be shocked. Just use some common sense, please. Just a little bit. Just ask someone. Just Google it. Okay, last movie of today we have Ready Player One. Yes. Cannot wait for this to just be a thing, because this is awesome. And honestly, it's so imaginative what they do with this, and it's exactly what I imagine like a gaming world to be. Okay, so technologically wise, is this possible? I mean, yes, definitely. We already have proof of concepts for pretty much all of the things that are in here. So we have VR that works quite well. We have sensors that you can place on your body already with things like mocap suits. We already have, large online multiplayer games with hundreds of people in servers. So it certainly is possible, and all we need then is to scale this up. So what we need to do to really make this a reality and to this degree of detail is going to be enhancing mocaps and being able to really monitor every part of the human body to really engross yourself in this world, which is certainly within the realm of possibility within the next few years, if we really wanted to. But the main thing I would say with this is just the hosting of something like this. It's making sure that everyone in the world has access to, super fast internet to be able to be a part of this world without, errors and things, which arguably something like Starlink is a stepping stone towards that. But more importantly to me, it's the hosting of the actual system, the world. In gaming, you tend to have server-based and you have host-based games. So I don't think people do host-based much anymore, actually. When I was younger, you would join a COD game and you would be able to find out who the host was, because it would be the one that was lagging the least. But typically now you get server-based. But what that requires is to have a server somewhere in the world which is storing all the data for the game. It's communicating with all the players, and it's allowing you to live within that world. And the scale of this universe that's being created is so large, and it has so many people in it, so many more than you would ever have from any existing game. You're looking at millions, if not billions of people within this world. Hosting all of that and being able to do it securely and safely and quickly and reliably and all these things is just a logistical nightmare. But certainly, particularly with Facebook looking at the metaverse now, and with Starlink and 5G and all these different things, I think we're closer than a lot of people might expect to something like this. Well guys, that's all we have time for today. I hope you enjoyed this first episode of Engineer Reacts. Engineering and technology comes into so many movies, and it's so often abused in so many ways or treated as some kind of magical science. So if you have any movies you'd like me to react to or just try and explain a little bit more, then please do let me know. I'd love to hear them, and then maybe we can get that in the next episode. But in the meantime, guys, I hope you have a great day, great evening, great week, and I look forward to seeing you in the next one. Take care of yourselves.
We are the only nation that builds water-cooled, graphite-moderated reactors with a positive void coefficient.
A bit of explanation in case it's of interest to you. When he's talking about the positive void coefficient, that's actually one of the main driving factors in the disaster. When you have a positive void coefficient, what that means is the higher the temperature of the water in the reactor, the higher the reactivity of the reactor, i.e. the more reactions are going on and the more power is being produced. What happens then is, as more power is being produced, more heat is produced, therefore the water gets hotter, therefore the power goes up, therefore the water gets hotter. And you get this feedback system. It's a positive feedback which produces more and more power to a level that cannot be controlled in that regard. And the only way to control that is through the use of the control rods. Now, during the tests that they were doing prior to the disaster, they had removed the control rods. So there was nothing that they could alter to reduce the reactivity. And that's what caused the disaster. Now, in most modern day pressurized water reactors, you actually have a negative void coefficient, which means the hotter the water gets, the less reactive it gets. So if it gets too high, the water gets hot, it gets less reactive, it cools down, and then you get this actually self-maintaining system where if you get any kind of inrush in power for any particular reason, the temperature change in the water actually helps to lower that down again. So it's the opposite. It's extremely safe in comparison.